Hey everybody, thanks for joining me tonight. Let me know if my audio is okay. Hopefully I sound okay. And let me know if you can see the window here too. Although this is just about as big as I can make the text, and you'll see why that is in a few minutes. Today we're going to be going through this Play with Docker classroom. They have a series of tutorials for developers. They have other series of tutorials as well, but we're going to be focusing on the developer tutorials. The really cool thing about this is the only thing you have to have is you have to have a Docker ID. I sent out a link earlier to tell you how to get one of those. It shouldn't take you too long to register if you haven't already. Okay. Sounds like the video is a little bit blurry. Let me see if there's anything I can do about that. Okay, I'm going to try to reduce the quality of my video just a little bit, see if that helps. But just let me know, keep me posted as we go through this, and I will try to soldier on in the meantime. Very laggy. Okay. Looks about the same. Okay. Okay. Sounds like it's looking better. We're going to keep going here. The URL for this tutorial is training.playwithdocker dashes between each word .com/dev-stage1. That is training.playwithdocker.com/dev-stage1. And I think Bradley's going to post that link in the chat if you just want to click through there. I'm going to go on through to this beginner tutorial, and we will get started playing with Docker. First, I should probably tell you some of the reasons why you might actually want to use Docker. Docker is a great way to ensure that you have common development environments between developers. So if your application uses a specific stack, let's just talk about a Node application. You're going to have a version of Node that you're running, a version of NPM you're running, and then you're also going to have a bunch of dependencies that are all at a specific version. You can build a Docker file that will bring up a Docker container that is consistent. Each of your developers is working with the exact same development system in that Docker container. It's basically like a lightweight virtual machine that you can ship around with your source code. There are other uses for it too. You can actually ship a Docker container into production so that your production environment is exactly like your development environment. And I've used it for some other things. I find it's hard to manage dependencies in Python, so I've actually shipped like an internal application, Python app, in a Docker container just to make sure that the dependencies are right for everyone who's trying to run it. And that worked out reasonably well. Okay, let's see. I am going to log in here. This is where you will use your Docker ID. If you haven't created one, you'll have to have one before you can go past this step. And once you have logged in, you'll see this. You'll see what looks like a web page on the left-hand side and then a terminal on the right-hand side. Good question, Guy. You create a Docker file that defines your Docker container, and then that Docker file can be committed into your source code repository along with your source code. So then anyone else who pulls down that repo gets your Docker file, and they can replicate that environment exactly using that Docker file. Okay, task 1, we are going to run a single task in an Alpine Linux container. We're going to do that with this command. Also, I will give fair warning, my system is absolutely pegged right now, and a really strange thing I've noticed about this application is that when my system is pegged, it will invert the letters that I type. It'll put them in different positions besides when I press them like that. I'm not sure why it does that, and I promise that's not just an excuse for me being a very bad typist. All right, so what we have just done is we told it to run this Docker container, Alpine. It did not have the Alpine image. You see here, unable to find image Alpine latest locally. So what it did is it pulled that down from Docker Hub, which is sort of like a repository of Docker containers. Think of it as like, if you're familiar with NPM, think of it like NPM or any other package manager you might be familiar with. Think of it like a package manager, but for container images instead of, you know, JavaScript libraries or whatever else. Alpine is actually the Linux distro. So that's what that is. And latest, we're going to grab the latest version of that image. So this is really, I don't know, in a lot of ways, this is not a super useful Docker image. You would usually build something on top of this. Like maybe you would have Alpine Linux running MySQL or something like that. But this is just like a bare Alpine Linux image. All right. And here we go. Step 2, Docker keeps the container running as long as the process it started inside this container is still running. Hostname is actually the process we started. So we ran the Alpine image, and then we started the hostname process. All that does is it just spits out the hostname of the machine that you run it on. That ends immediately. So that container came up, ran hostname, and then ended. That container is gone now. Let's do this. So we're going to list. That's what ls is, list. We're going to list all the containers. And we're doing all because if we don't do that, we won't get containers that have exited. We'll only get containers that are running, which actually let me show you what that does. In this case, it should just show us nothing. Yeah, it's just a table that's empty. And so large. I'm gonna size this out a little bit and run these again so that the tables are actually readable. There we go. It's still a little wonky, but this is better. So this is our container ID, A1F, whatever. This is our image. This is our command, hostname. It was created 2 minutes ago, and its current status is exited. That's because all we did was run that hostname process. Okay, moving on. Okay, now we're going to run an interactive Ubuntu container. This is going to bring up a container and just sort of let us use it like we would if we were sitting at a computer running Ubuntu. It's not going to be a GUI. It's just command line Ubuntu. But let's type in this command and see how many characters it inverts for me. Okay, before I run this, I'm going to sort of break this down the way they have here in their explanation. Let you know some of the options we're using with this command. Interactive tells us that we want to interact with the session. So we want to be able to type stuff and have it be typed on this container while it's running. TTY allocates a pseudo TTY. Honestly, I do not know what that means. I don't have that in my head right now. RM tells Docker to go ahead and remove the container when it's done executing. So that other container, the Alpine container, I think I said that it was gone. It's not gone, it's still there, but it is exited. This one, once it exits, it will be gone since we're adding this remove option. Let's go ahead and run that. Oh, and the process we're going to run is bash, which is just the born again shell. So just the sort of baseline Linux shell that you get with every Linux distro nowadays. Oh, what have I done? The comments on this video are all going to be about how I can't type. Which will be true, but it won't be as bad as it appears. Okay. Now we're doing something interesting. It looks like it just inside that container now. We're no longer on the original virtual terminal that we were in, which itself is probably a container. We are inside the container we just ran. And this next command will sort of reinforce that, or this next series of commands. First, we're going to do ls/, and that's going to list the directory contents at the root directory on this container. So that's that. Not a whole lot you can determine there. Now let's do ps aux. This will tell you what processes are running inside the container right now. So we're running bash and ps aux. And now we're going to cat out this etc issue. And that tells us that we are running Ubuntu 20.04.1 LTS. So we are inside an Ubuntu machine right now. And that's the machine we just pulled down. Now we're going to exit which will take us out of that container. And we're going to run that same command again. We may run that same command again. Also, if you know that you can use the arrow keys to navigate through your history, it will not work across containers. So whatever you have typed inside your container, I can't hit up to get back to that in the history. It sounds like we're having some lag again, maybe.
On my side, it's just a little blurry. I'm not sure if there's anything in my
Okay, I've got a question. I'd like to know if you can secure the container so it acts like a black box, or do container hosts have access to all contents? I don't know the answer to that question. I would imagine that you can. Are you concerned about the file system, about not having access to the file system? I have not tried to do that. But in general, your host would at least be able to access the container in some way, even if that's just like bringing up a shell on the container, kind of like we did just now. Yeah. I think by default the file system on the container is sort of contained within the container. You would have to be in the container to access it. So if you set up some security measures on the container, you'd have to have access to those in order to get to the file system. You can map volumes on the container to the host machine. So I could say, I want this folder in my projects directory to be mapped to this location on the container, and those two would be so if I make a change on my system in that directory, then that change will also be on the container, and if I make a change on the container, I would see that as well on my host machine. So yeah, you wouldn't want to do that in your case. That's a pretty useful thing to do in a lot of cases. As a developer, if you're setting up development environments, you can have the container see your build directory, and maybe you run your build on your computer, or maybe you don't. Maybe you would want to run it in the container, but you could have a directory that's common between the host and the container. Okay, I think what I'm going to do, I don't have a lot of levers I can pull right this moment to improve the video, I think. So I'm just going to try to bump the font size up a little bit, and hopefully that is still usable, and maybe we can see it a little bit better. Just let me know how that goes. Yeah, and their fourth step is exactly what we just did, to demonstrate that now we're on a different machine than we were on before when we were inside the container. All right. Oh yeah, this is an interesting point here too. You can commit a container to make an image from it. So what we've done is we pulled down a container image. We spun up a container from it, and then we can go in and make whatever changes we want on that container, and then we can create a new image from it. But they're also saying you should avoid that whenever possible, because it's better to use a repeatable Docker file to build your image. And that was what I mentioned to Guy earlier. The Docker file allows you to repeatably spin up the same container every time. All right. Yeah, and there are so two concepts versus a container, and then maybe versus a Docker file. The image is sort of the basis, the original basis for the container. That's what we're pulling down from Docker Hub. So the ones we've done so far are Alpine. We pulled down an Alpine image, which is just like a bare Alpine Linux install. We pulled down an Ubuntu image, which is just a bare Ubuntu Linux install. Then we've got containers, which are the sort of virtual machines that we've spun up from those images. So it started out as an image. From that, we created a container, which is now like a machine that we can run, a virtual machine that we can run. And then we have Docker files, which we're going to look at later in this tutorial, that allow us to sort of codify some changes to that container once we have the image. And that'll make sense more once we actually get into it. All right, we're going to run a background MySQL container. One thing I want to note, in case some of you are not familiar with the terminal, what they're doing here with these backslashes is they are escaping that next new line. So if in general, when you type out a command, if you press return, that runs the command. By typing the backslash before you press return, so that you can sort of have a multi-line command, it escapes the default behavior of that return or enter press. So that does not run the command. Instead, it just gives us that new line character, and the shell ignores it. That has nothing to do with Docker, by the way. That's just a shell thing, shell trick. And it will be borderline miracle if I get all this typed out without any typos. Let's see how it goes. Looks reasonable. Okay, we're going to give it a moment to pull that down. Okay. Thanks for stopping by, Gordon. Okay, now we're going to look at a list of running containers. Oh, wow. Nope, nope, nope. Okay. This container, the way we ran it, and really the way it's intended to be run, is a little bit different from those others. This one is MySQL, and what you would generally want to do is you would want to bring up your MySQL server and just leave it running so that you can, use it to access your data, to store your data. And that is kind of what we've done here. And let's go back up to this command. I should have walked you through this when I typed it in. Detach will run the container in the background. If you have a container like that, it would just show you the output of that container, and it would just be locked. Your terminal would be blocked at that point until you exit the process that's running inside that container. By using this detach option, we have allowed it to keep running in the background, and we can continue to use our terminal. Our terminal is not blocked. And then name is just assigning the container a name. And the E option is setting an environment variable. Some containers, actually, let me see if I can pull this up for you and if you can see it. Yeah, I think you're going to be able to see it. I'm going to show you the Docker image. If your Docker image is well documented on Docker Hub, you'll have some information about how you can access or how you can use this image, how you can use a container with this image. And I'm willing to bet the MySQL image is pretty well documented. So it will probably tell us what environment variables we can set to make different configuration changes inside the MySQL server that's running in that container. I'm going to flip back over and we'll keep going a little bit while that happens. I'm not sure why it's being slow. Okay, we've seen that the container is still running. Okay, now we can look at logs for the container. Let's try that. Okay. If we had not detached that container, this is what we would be seeing. We would see this output to the console to view it. And then container top. Top, I believe, is a process that lets you view running processes. And the last option there, the last parameter is the name of the container. It's the one we defined earlier with the name option. Okay. And this is telling us that the only process running on that MyDB container right now is MySQLD, which is the MySQL daemon, just the MySQL server. All right, now we're going to list the MySQL version using docker container exec. This lets us run a command inside the Docker container. Okay, let's try to break down this command. Oh, it's not going to give us a breakdown. I know that the IT option gives us the interactive terminal. Sorry, gives us the interactive, and T is probably TTY, so those are just shorthand options for what we used previously so that we could get the interactive bash terminal on that container. Then what we are doing is we are running the MySQL command. So we're running the command line MySQL client on the MySQL container. And then we're passing it some options as well. And the options we're passing it are the username we want to use to log into the database. We're passing it the password, and we're actually passing it that environment variable that we set earlier. Then we are also passing the version option, which should just spit out the version. Normally, this MySQL client would just drop you to like a new prompt inside the MySQL client, and you can start typing commands into MySQL. But by adding that version option, it's just going to spit out the current version of MySQL that's running. Let's see if this works. Okay, looks good. We are running MySQL version 8.0.22 for Linux. Okay. You can also use Docker container exec to connect to a new shell process inside an already running container. When I work with Docker, I use this one pretty frequently. Our MySQL container is still running right now. What if we need to have some visibility into what's going on, something beyond what the logged command would give us? In order to do that, we can use this command, which would allow us to have a shell on that same container. Okay, so it almost, if you're not looking closely, it almost looks like we're just back at a prompt, and we are back at a prompt, but we're at a different prompt. So now we are again inside the container like we were before. So they're going to have us run that same command. So this is sort of equivalent to what we did before, except instead of running it through exec and just getting the output, we're going to be running it inside the actual container. And if we put commands after this to do further troubleshooting or debugging or whatever, we are back at a prompt inside that container so that we can continue to run commands on it. Let's see if I can actually get this typed in. It's not cooperating. Does anyone have any questions so far? I know we're kind of covering a lot of ground here. And maybe I'm going too fast. Okay, there we go. That's the same output as before, but now it is, we're still inside the container. So actually we could go to our history. Oh, we can't go to our history, but okay, we could type that same command again and get the same output. If we typed the container we were in, the outer container, the host of this container, it would complain because it doesn't have MySQL installed. Only our MySQL container has that. And now I'm just going to exit this shell. I don't know why it insists on inverting those. Okay, and now you see the $sign, we're back in the host. Package and run a custom app using Docker. Now we're starting to get into the meat of it. Okay, now we're changing into this directory. A long time ago, at the first of this stream, we cloned a GitHub repository, and now we are going to change into that repositories directory. Okay, we are there. And it's going to have us take a look at the Docker file. Guy, this might be of interest to you particularly. This is a very simple Docker file. The first line in the file is from Nginx latest. That means that is the base image of this Docker container. So Nginx being the popular web server. So this is going to be the latest Docker image for Nginx. And then from there, we are copying two files. We're copying index.html and linux.png. That's relative to the directory we're currently in. So if I list the contents of this directory, we should see those two files. Index.html and there's linux.png. So what it's going to do is Docker is going to pull down the latest version of that Nginx image, and then it's going to copy those two files from the current directory, the directory that the Docker file is in, and it's going to copy them to these locations on the container. It's going to copy them to usr share nginx html. Then it will expose two ports. So it's going to expose these ports to the host, I believe. Documents which uses. And then it's going to run this command. And it's running this command inside the container. So it's running nginx -g daemon off. And when it's set up as an array like this, when you're passing an array, it's as if you have a space between each item in the array. Okay.
I like that.
Let me, in order to make the following commands more copy-paste friendly, export an environment variable containing your Docker ID. If you don't have a Docker ID, you can get one. You'll have to manually type this command as it requires your unique Docker ID. Okay. So this is going to contain your Docker ID. I'm actually going to have to, I don't know exactly what my Docker ID is. So let me look that up. And we're going to export. Oh, no telling what it's going to type. This thing does not like me using Play with Docker, streaming, and opening my password locker at the same time. Okay. I probably could have guessed what that ID is, but now we know. And of course, that's going to be your Docker ID. This will confirm that what we just did worked. So we can echo. Echo just means write it back out to the console. So we're going to echo Docker ID. And when you reference an environment variable, when you set it, you just use it bare like we did there, but when you reference it later, you preface it with a $sign. I don't know why. I'm sure there's a very good reason for that. And it looks like it worked. So we are good. And now we are going to build an image. Use the Docker image build command to create a new Docker image using the instructions in the Docker file. Now, your Docker file would travel around with your repository if you wanted to use it to replicate your development environment. It would travel around with your repository, and whenever someone new pulls it down, they would use Docker image build to build that image based on that Docker file. Okay. Let's break this down a little bit. The options for this command. We're using the tag option, which allows us to give the image a custom name. And in this case, that's going to be our Docker ID, whatever you entered there. And then / Linux_tweet_app. And then this is just the version. So we're christening this version 1.0. The dot tells Docker to use the current directory as the build context. That means build the Docker file that's in this directory we're in now. Let's go ahead and run that. Okay. The first thing it did is it downloaded a newer image for Nginx. Then it copied these two files. It exposed the ports we told it to, and it ran this command. Okay, now we have an image, but we don't yet have a container. So we need to run the container. We'll do that with Docker container run. And they've got a lot more going on here. We're using the / trick again to escape the return, so we can spread this command out across multiple lines. That's not what we want. There's a note up here about publish. As this container will be running an Nginx web server, we'll use the publish flag to publish port 80 inside the container to port 80 on the host. Okay. So that means if our host gets traffic on port 80, that is going to be forwarded to port 80 on the host. I think that's what that means. I also think we'll find out pretty soon. Okay. if anyone is in the chat and feels like sharing, I would be interested to know if you have any Halloween plans. I would like to know what Halloween plans look like in this world. Okay, I think I've got everything there. All right. It looks like this command gives us no sort of feedback. I assume that's okay. Oh, okay. And this says click here to load the website, which should be running. Let's try this. Try to open this in a new window. And maybe while that's happening... Oh, this never really loaded, did it? Oh, it did. Oh, okay, here we go. Here's our Linux tweet app. That's pretty cool. That's running inside the Docker container. And this apparently is a URL we can use to hit our Play with Docker instance that we're running on right now. Yours will probably be different, I suspect, than what I've got here. Very cool. All right. Now, before I lose the thread on this, let me see if I can find the documentation for this MySQL image. I promised this like 10 minutes ago. You got this page isn't working. Did you get any additional output from this command, this Docker container run? These will have, yeah, here we go. Here's a list of environment variables you can use to configure your server. You can set the password, the database. You can set the user and password. Oh, to create a new user and set that user's password. Okay, so if you want to create a new user besides the root user that's going to automatically be there. Allow empty password. So you can just set any of these environment variables and that will augment the server with that configuration. No additional output. And it said this page isn't... I am not sure about that. What about the earlier commands? Any additional output from any of these earlier commands? I'm trying to think of which ones are relevant. It's probably just the one above that would have that you would have seen the output from. Let me know. Yeah, the build command. See if there's anything on that. Okay. If you don't get it, didn't send any data, you might just try refreshing it. And well, no, if it didn't send any data, if it didn't send any data, that sounds like the server's not running. So I'm not sure exactly what would have caused that. It's not a huge deal because oh wow, that's a huge mess. Okay. And what they're telling us here is that by using that force option, it will shut it down as well. Otherwise, that would be a two-step process. You'd use this Docker container stop command to stop it, and then you could remove it and you wouldn't need the force. Tamara, I don't think this won't affect anything else we're doing, I don't think. I guess we'll find out soon, but yeah, hopefully you'll still be able to do everything else and it won't affect you, but yeah, so now we've stopped the container, we've removed it, and here we're going to modify a running website. Yeah, okay. This is a little bit of what I was talking about earlier. I mentioned that you could mount volumes from your host machine on the Docker container, and that's what this is telling you how to do. It's saying when you're actively working on an application, it's inconvenient to have to stop the container, rebuild the image, and run a new version every time you make a change to your code. But that Docker file we saw earlier, do you remember it was actually copying the source code onto the container? That only happens when the build happens. So that means every time you want the copy to be updated, you have to run the build again. And that's what they're saying you don't want. And they're absolutely right. You definitely don't want that. This is the alternative. I'm going to try with great difficulty to type in this command. Actually, I think what I will do is I'm just going to click this command. Okay. And I'm going to explain this to you so you'll have plenty of time if you want to type it in just to sort of build that muscle memory. I kind of like to do things that way when my computer is not absolutely freaking out. Okay. So what we're doing here is we are running a container. We're running that same container as before, the Linux Tweet app. And we're using a lot of the same options. We're detaching so that the server can keep running in the background. We are publishing that port 80, this mount. Okay. And what we're mounting is we are mounting the source we're mounting. That means the location on the host computer that we're mounting is this, which doesn't look like anything, but it actually is. This is, it's, I just realized what's happening. I'm clicking on this and it's trying to run this command again. Okay. This pwd is your working directory. That $sign and the parentheses enclosing the pwd, that is telling it to run that command and insert the output from that command at this point. So the source is going to be whatever the current working directory is, the path to the current working directory. You might think you should be able to use just a dot there, which is kind of the Linux, Unix shortcut for this directory, but I believe I'm remembering correctly that will not take a relative path. So you have to put an absolute path in there, and pwd will return that absolute path of the current directory. So that way you don't have to hard code this directory in if you were going to script this command so that you could run it over and over again. you could potentially move that script somewhere else, and it would always put in the path to the working directory there. And then the target this is where that is going to end up on the container. So this is going to end up at USR share nginx HTML, which I assume is like the static HTML serving directory for nginx, the default directory. All right. We have done that now. Oh yeah, they say that here. Remember, from the Docker file, that location is where the HTML files are stored for the web app. And now our website should be up. Next step is we're going to modify that site that we have running on our Docker container. Copy a new index.html into the container. The Git repo contains several different versions. Okay. So what we're doing here is we're copying a file called indexnew.html, and we're copying it basically over top of index.html. See if I can actually type this in without too much hassle. In case you're curious, this is pretty much the extent of my Halloween plans. I'm wearing this really cool skeleton shirt that I borrowed from my daughter. All right. Okay, that should have copied index new over top of index. Now we're going to go reload this, and I assume we will see something different. Ah, look at that. We have an orange background. So that definitely worked. And I think you can see how that is a lot more convenient than having to rebuild the image every time you want to make a change. And just to be clear, copying is not the only way that you could make a change on a running container. Guy says I'm doing more than him for Halloween. Yeah, I understand. They're like, what can you do right now besides wear a sweet skeleton shirt? So yeah, just my recommendation, guy, is candy and horror movies, maybe. My family will not tolerate the horror movies, so I am left watching them alone. But I'm okay with that. If it's watch them alone or don't watch them at all, I'll watch them alone. All right. Oh yeah. So what I was saying is, you don't have to copy over an existing file. I could go edit that file. Well, if my computer were the host computer, now we're in a weird situation where like we've got this sort of virtual environment that we're using through this website. But if this web server were running on my computer is the host, I could, in whatever editor I wanted to use, Visual Studio Code, Sublime Text, brackets, Vim, whatever editor I want to use, I could open those files and edit them and save them, and then I could refresh, and I would see those changes on the page. Halloween and Animal Crossing. Yeah. That's sort of the one of the few common social experiences. Not that it's 100% common, but I know a lot of people that are doing that one. All right. I'm going to click through these because I don't think it's going to add a lot for me to type them. The first thing we're doing is we're stopping and removing that container, just like we did before with the Docker RM with the force option, so that we stop and remove it all in one shot. And now we're going to rerun the current version without a bind mount. So this is I think this is what we did to begin with, basically, is to run it without the bind mount. And now we should see it back in its original form. Yep. Got the blue background again. And then we're just going to remove it again. How's everybody doing? Anybody getting behind, having problems? I think what I'm going to do, we've been going for a little bit over an hour. I'm going to take a quick break, and then we'll come right back and pick up with updating the image. And I think we're going to basically commit some of those changes, maybe the orange background, into our image. All right. I will be back in just a couple minutes. All right. Thanks for your patience, everyone. We are back. And Guy asked a question while I was on break there. Still trying to wrap my mind around the bigger picture of Docker. Can you elaborate a little bit, Guy, about, is it like the understanding what the pieces are, like container versus image versus Docker file? Is it kind of that where the confusion lies? Or is it more around, what does this do for me? How am I going to actually use this? And I'll try to fill in some of those gaps if I can. In the meantime, we're going to go on to these next steps. We are going to update an image. To persist the changes you made to the index.html file into the image, you need to build a new version of the image. And that's what we're going to do here. Let me see if this will let me type without making me look too foolish. Just a little bit foolish. All right. Nope. Okay, 2.0. Versus a virtual machine. Okay. Yes, and all that versus a virtual machine. Okay, gotcha. So still some confusion around the container, the image, and the Docker file. How does it all fit together, and then what do you do with it? And what does this do for you versus a virtual machine? My understanding of this is still fairly rudimentary. So my understanding, I'll start talking about the container versus the virtual machine. My understanding is that this is a lighter weight virtual machine. It's doing a lot of the things for you that a virtual machine would do, but it's much lighter weight. And there are a lot of different senses, or at least two different senses in which that's true. One is it's lighter on system resources. When you bring up a virtual machine, it is an entire virtualized computer running inside your computer with everything that entails. Docker, I believe all of your Docker containers run against a common kernel. Docker it sort of takes dry, don't repeat yourself, and moves that out into infrastructure. So everything is recycled as much as it can be, which makes it lighter on resources. Also, think about that Docker file we looked at. It's just a few lines of text. So it's like maybe 100 bytes or 200 bytes or something like that. If I wanted to ship someone a development environment that was a virtual machine, that would be, even a small one would maybe be 100 megabytes or somewhere in that region. It would be way more. It would really add a lot of bloat to my repository. It'd make it harder for people to pull that down when they're coming on board. So it's just a lighter weight version, a lighter weight method for doing all those same things that a virtual machine could do for us. And then the way that the different pieces fit together, it's like an image is the basis for a container, and then a container is actually the Docker equivalent of a virtual machine that's running somewhere. And then a Docker file is a set of instructions that takes you from an image to the container that you want for this project. So it's running whatever commands it needs to run, whatever Docker commands it needs to run to get that raw image into the container you need it to be. I hope that's helpful. Feel free to ask follow-up questions if it is not, or if I need to fill in some more gaps for you there. All right, let's see what we can do here about building this image. Looks like that was successful. And what we did is we built a new image. We gave it a tag. This one's 2.0, whereas the other one was 1.0. And we built that from this current directory that we're in. So it's building from the Docker file that's in this directory. All right. Okay, now we're going to look at the images on this system. Dorkek, that's pretty good. Dorkek, okay. Here we go. We've got another table that's all out of sorts. Here's the repository. raddevon/Linux tweet app. And this is tag 2.0. So this is just giving us a list of all the images Docker has stored on this computer. And if you look down here, all these are the ones that downloaded previously to run the commands we've been running. Nginx, Alpine, MySQL, Ubuntu. And then these are the two that we created. Bradley's posted a link that looks like it might be helpful from Backblaze. VM versus, I'm assuming that says container. So that might be worth exploring too. We know our image built because it's in our image list. Now we're going to test the new version. And I'm just going to click through on this. I don't think there's anything new we're doing here except that we've changed the version number, so it's going to build from the new image. Guy asks, so sharing a Docker file with someone allows them to rebuild the complete lightweight virtual machine like Docker container with all the versions, environment variables, etc. That is exactly correct. Yes, that is what it allows them to do. You can give them a text file that's a few hundred bytes. If you've got a really wild one, maybe it's a 1K or something like that. And based on that, they can build an entire environment, whatever environment you've spec'd out in that Docker file. That's a very good explanation. I wish I could have come up with it. But thank you for sharing it. All right. Yeah, I'm going to click through this, run our container, run a container from our new image. That's what I'm doing here. Now, we will, I wonder if we can just, can I just refresh this? This is not useful in any way, but I'm just curious if I can just refresh this. Oh, looks like I can. Now we are back at the web server running our new image. Okay. The web page will have an orange background. We can run both versions side by side. The only thing we need to be aware of is that we cannot have two containers using port 80 on the same host. So we could actually bring up another container. Oh, and in fact, we're going to do that. No sense in talking about it. Let's just get right into it. The difference here, there are two differences in this command versus the last one we ran that's running the new, that's spun up from the new image. This one is spun up from the old image. It's using 1.0 of our image. And the publish has changed. Instead of publishing 80 to 80, we're publishing 8080 to 80. And that's because we can't have two applications on our host machine running on port 80. So for the host machine, which is the left side of the colon, we're changing that to 8080. But we're still running the same image, so it's still going to expose 80 on that container. So what we're doing is we're taking 8080 on the host and mapping it to 80 on the container. Hopefully that is confusing enough. Oh, it's working now. Awesome. Glad that panned out, Tamara. I'm probably pronouncing your name a different way each time, so apologies for that. Okay, we should have another container running now. Actually, let's see if we can... How do we do this? Docker ls? Nope. Docker ps? Nope. Just to see if I can see that both of these are running. Yeah, okay. Oh, also our MySQL container is also still running. But here we go. Here's our container running 1.0. Here's our container running 2.0. And can we see the port mapping? Yes, we can. Here on the 1.0, we're mapping 8080 on the host to 80 on the container. And then here on 2.0, which is the first one we brought up, we're just mapping 80 on the host to 80 on the container. Now, let's go to this site. These URLs, by the way, are some kind of magic that Play with Docker is doing. This is not anything you do on your own computer. If you had this set up on your own computer and you were running Docker and had these two containers up, you would go to your web browser and you would go to like localhost :80, or you could just leave that off because that's the default port for web. And then in another browser window or another tab, you could go to localhost :8080, and that would give you this version that we're looking at now. Very cool. This is a pretty good tutorial. Maybe it's, I don't know, maybe it's putting you in the deep end a little bit, but it's covering a lot of ground. Push your images to Docker Hub. Docker Hub, if you recall, is what I described as sort of a package repository, but for images. So it's where we're going to get the Alpine Linux image, the Ubuntu image, the Nginx image, the MySQL image. All those are coming from Docker Hub. And now what we are doing is we've got our custom image that we created on our computer, but it's not on Docker Hub, and we're about to push it up to Docker Hub. And this would allow someone who's collaborating with us to pull down this image and base a container on their computer on that image. So if you had a Docker file that you wanted to write against this image would have to be up on Docker Hub, or no one else would be able to build that Docker file. No one would be able to build an image from that Docker file. I understand how this stuff is confusing, all the different terms, because I am getting them confused in trying to explain it. List the images. Okay, this is sort of what we did before, except instead of listing containers, we're listing images. Let's go ahead and do that. And it looks like we're filtering. but let me confirm that. Well, they're not going to tell us. I believe what this is doing is we're running the Docker image command, and then we're listing the images, ls, and then we're passing an option f, which I assume stands for filter, and then this is the value of our filter, reference equals, and then we're inserting our Docker ID in here, slash, and we're saying anything after the slash. So we're listing any Docker images that start with our Docker ID slash, which is just these two. Just out of curiosity, let's see what this would look like without the filter. I would suspect that this would show us these two, and it would also show us Nginx, Ubuntu, MySQL, so on and so forth. That may be it, actually. Alpine, yeah. Yeah, that's pretty much what we're seeing here. Okay. Before you can push your images, you will need to log into Docker Hub. This is interesting because I know that this tells you not to put credentials into this terminal. In fact, I think that's the first thing it says when you do this. I'm not super cozy doing this here. So I think we're just going to kind of walk through this and not actually enter it. I would kind of recommend that you don't either. I find it pretty odd that they include this in the tutorial after when you launch this terminal, it tells you not to put in any credentials. But I don't think this will matter. We just need to understand what's happening here. If you were doing this on your machine, if you were in your terminal emulator and you had Docker installed, type Docker login. There's no harm in doing that. I'm just a little bit wary of doing it right here. But what we would do is we would type Docker login. It would ask for our username and password. We would enter those, and that would basically authenticate the command line interface, the Docker command line interface with our Docker ID, so that anything we push against our user account, basically. I don't think you can push anything to Docker Hub anonymously, so we would be required to do that. I'm relatively certain, but actually, let's just give it a shot really quick. I'm going to see what happens if I try to push. Yeah. Requested access to the resource is denied. So it would only let us do that if we had logged in. And then they want us to just push version 2. Not really much difference there. Docker image push is the command. And then you type the full name of your image and colon the version you want to push. Oh, it is pointing this out, which is really interesting. I mentioned that Docker is sort of dry, but applied to infrastructure. And here's an example of that. This push of 2.0 for several of these layers is going to say layer already exists. So it's not going to push anything there. It's basically going to say that's just like that layer already exists. That layer is on a different version. So you can go get that from the other version. And then here are the layers that are different, and that's what makes up this version 2. And then if we had done this, we would be able to navigate to this URL, which would be our Docker Hub. And it would be a home for all of the Docker images that we have pushed. Imagine your GitHubs, all the repositories that you've pushed up. This would be that, except for Docker images. check out the introduction to a multi-service application stack orchestration. I don't know how far we're going to get into this, but this is going to start making it really practical for web development. Everything we just did is certainly useful, but there aren't many applications that are going to just have one service, just one application running. Just about the only thing I can think of is like a static website that's maybe running on Nginx. So then you would just need one container, but most things are going to need, at least a couple of containers. Let's think about WordPress. So you're going to have a PHP server that's serving up WordPress. That's probably one container. And then you're going to have another container that is your MySQL to serve up your database. And then those two containers are going to have to talk to each other. And that's what's meant by container orchestration. It's setting up your containers so that they can talk back and forth in the ways that they need to. Before we really jump into this, does anyone have any questions, any sticking points, any gaps I can try to fill for you? I'll give you a few seconds to think on that and ask any questions you have. Thanks again to everybody that's hanging out. I know it's sort of a one-way thing, me talking to you, but I still feel this human connection that we all crave. All right. Hopefully this does not require us to log in. I don't think it does, at least not for this early part of it. All right, I don't see any questions. Feel free to ask anytime. I'll share screen and try to answer what I can. But let's get started here. I'm just going to click this command to run it. Okay, that cloned a repository called link extractor, and then it changed into that directory, and it checked out a demo branch. Again, this is all happening inside this container, so this is not doing anything on your computer. Oh, okay, now we're going to check out a different branch. We're going to check out step 0. And what does tree do? I don't actually know tree. Okay. Just shows the directory structure. The link extractor .py file is the interesting one here. This is a Python application. We're going to take a look at it. Okay, it's a pretty short script. It uses Beautiful Soup, which is a, I forget what it's called, but it lets you scrape. Oh yeah, it's a scraper. So it lets you scrape web pages. Or actually, I guess it's an HTML parser, so you could use it to scrape web pages. Okay, this is a simple Python script that imports 3 packages: sys, requests, and bs4. bs4 being that Beautiful Soup library. You don't necessarily have to know about Python for this to make sense or be valuable to you. The only things I think you need to know here are that sys is from the standard library, and then requests and BS4 are third-party packages, so you would not have those by default if you just installed Python, or if you got a hold of a computer that had Python already installed. You wouldn't expect that that computer would have requests or beautiful soup. All right, now we are bash permission denied. It does not like us running the script. Okay, I'm just going to click through some of these commands to make things a little less tedious for you and for me. ls lists the contents of the directory. -l, I'm not sure exactly what that does, but it gives us additional information. Otherwise, if we just ran ls, it would just show a list of files. So this is giving us some additional information. This first section here, these are the permissions. R is read, W is write. There should be, I think, an X in there if we were able to execute this script, if we were allowed to execute this script, and there is not. That means that we are not allowed to execute this script. And the next thing we're going to do here, okay, they're telling us we can either change the permissions using chmod, which just modifies the permissions. And here we are, I'm not sure exactly, we're adding X, so we're adding execute, I believe, is what's happening there. And we're adding it to this script, which would allow us to run it in the manner we just attempted. But, oh, thanks for stopping by, Tamara. Happy Halloween to you. All right, they're not going to have us do that. They're going to just have us run it through Python. Python will be executable, and then we can pass it this script, and it can run it that way. Oh, Python command not found. Is interesting. I don't think they anticipated this one. Why is it doing this? Did I miss a step? I don't think I did. I don't think I missed a step. So I think this image we're running on, probably their default image used to have Python, but it doesn't any longer. So I think that's why we're getting a different error than what they are. That's just me guessing though. But I think if we move on, this will solve our problem too. Now we're going to check out step 1. All right, we are in step 1. Now we're going to call tree. This time we have a Docker file we did not have before. This is going to serve as basically a demo of what you were asking about at the very beginning, Guy. Let's look at this Docker file. Okay, the base image is Python version 3. And then it has this label that's not germane to how it functions. Then it's going to run these two commands. The first one is going to install beautiful soup. The second one is going to install requests. And that's going to take care of our dependencies. Then it's going to change into the app directory. That's going to be the working directory. This script that we've been trying to run is going to be copied into that app directory on the container from the host. So copied from the host to app on the container. Then it's going to run this command, the chmod command, to make this script executable. And at that point, we're defining an entry point, which means this is going to be the script to run when this container is executed, when this container gets run. Now we've got to build this. I'm just going to click through. All right, downloading the Python image. It's kind of a big one. All right. Python image is down, and our container is built. Okay. If the build was successful, I'm sorry, the image was built, not the container. Now let's list our images and make sure it's in there. There is step 1, which is the one we just built. Link extractor repository, tag step 1. 28 seconds ago. That is our image. Here's a prime example. This container is 890, or the container image is 896 megs. If we had to ship the image, we would add 896 megs to our repository. But instead we have that that Docker file. Let's see how large that Docker file is. 265 bytes. Okay. Now we are just going to run the link extractor. I'm going to just click through this. This is Docker container run, so we're running a command on the container. We want an interactive session. We want TTY, whatever that is. I apologize that I don't know. We want to remove this container after it has executed. And then this is the image we are bringing up as a container, link extractor, step 1. And this is an argument we're passing in. Since we defined the entry point in the Docker file, it's going to run that command if you run it without giving it a command. And then this will be passed into that command. Let's see if that works. This outputs a single link that is present in the simpleexample.com webpage. And that looks like the same output we got, so I think we're good. Let's try it on a web page with more links in it. Now we're going to try it on the Play with Docker training page, which had, I don't know, oh, it has quite a few links. Okay. Very cool. This looks good, but we can improve the output. For example, some links are relative. You can see those up here. These are relative. And then these are absolute. Step 2, let me take a look at this. We are running up against time. I think we can probably get through this step, and that may be where we call it for this session. All right. We're going to check out step 2 in our repository, and let's see what changes that brings. Looks like we have the same files as before. but apparently there have been some changes in the script that we're going to take a look at. Oh yeah, this is okay. It's not too crazy still, but it is imported this additional library from import URL join. I'm going to venture a guess that they're using that to take the relative URLs and turn them into absolute URLs. And then, okay, then they're assigning this base equal to URL. Yeah. What is this exactly? Links.append text. Yeah, okay. I'm not going to spend a whole lot of time trying to figure out exactly how this works. That's not really important to what we're doing here. But let's go ahead and build this image. And that's just docker image build -t, which is tagging the image. We're building it as link extractor step 2. And we're building from the current directory. We've used a new tag, step 2, for this image so that we don't overwrite the image from step 0 to illustrate that they can coexist and containers can be run using either of these images. We kind of did that before. Now let's look again at our images. I'm going to let it type for me. We've got link extractor step 1 and link extractor step 2. And then we've also got the Python that it had to pull down to build that. Now we're going to run exactly the last command we ran through the container, except through the new container, the step 2 container. And let's see what that looks like. Okay. Now it's formatted like Markdown. It's formatted like Markdown, and everything is an absolute URL. So if it was a relative URL before, it is prepending the URL we passed in to the URL. Pretty nice. Now we could open this up in anything that renders Markdown, and all of these would be clickable. These images, would they be? I guess they would be actual images. The images would be inline. That's pretty neat. Running a container using the previous image should still result in the old output. We can do that, I think, just by pressing up twice. Oh no, it won't be twice. It'll be a few times, because we did run some other commands. There we go. That would be the first one again. Let's go ahead and run that. Yeah, that's our old output format again. Those two images are coexisting on my machine, and I can bring up a container based on either one. All right. I think that's where we're going to call it. We've gone through a lot of stuff. I hope it didn't go too fast, and I hope you got something out of it. I hope to see lots of repos with Docker files that I can easily pull down and start developing on. This is really kind of a boon for the open source community, because that is one of the big barriers to getting involved in a new project, is having to get all the dependencies exactly right. And I was talking to a friend of mine earlier about an issue I had with an application. It ran perfectly on my computer, and then when I pushed it up to production, it was completely broken. And I eventually learned the reason was that Mac OS is not case sensitive. The default Mac OS file system is not case sensitive. So I had the incorrect, I had referenced a file using the incorrect case. I think the first letter was capitalized and I had referenced it as a lowercase letter. Mac OS, my computer, handled it just fine. I'm not saying that's good, but it worked perfectly on my computer. Then when I pushed it up to a Linux system where it was being hosted, it broke because Linux did not find that file with the lowercase initial letter. It only had one with the uppercase initial letter. So that file was just not found and generated a 404 error instead. And that's the kind of thing that Docker can get around because everybody is using the same environment. And if you're using Docker in production, you know that even the production environment is identical to the one you're running on your development machine. Hope that's been helpful. Thanks everyone for hanging out with me. If you liked this, then please subscribe to my channel and I will deliver more stuff like this and stuff about career too. I do a lot of that